Myself Prajulas, studying in Sri Venkateshwara College of Engineering, ISC third year. Now let's see the topic about mutation analysis fault-based adequacy criteria. What is mutation analysis? Mutation analysis is a technique used in software testing to evaluate the quality of software testing suite. It involves introducing small changes called mutations into a small program source and then rerunning the test suite unit to see if any test fails. The goal is to measure the effectiveness of the test suite in detecting faults or bugs in the program. What is mutation? Mutations are typically small changes to the code, such as altering an operator or swapping a condition, which is designed to mimic common coding mistakes that programmers make. The mutated codes is then executed with the test suite, and if the test pass, it means that the test suite was unable to detect the mutation, indicating the weakness of test suite. On the other hand, if the test fails, it means that the mutation was detected and the test suite is considered as effective. What is mutation analysis? Mutation analysis is the powerful technique for identifying weaknesses in the test suite, but it can be computationally expensive and time consuming since it requires running the test suite multiple times for each mutation. Despite this, it is widely used to industry and academic to access the quality of software test suite and to improve all the reliability and robustness of the software system. Now let's see the how does it work. Actual program and mutated program are compared and the both outcome of the program are then given as output. What is fault-based adequacy? Fault-based adequacy are used in mutation analysis to evaluate the effectiveness of the set of test cases in detecting faults in the system software. In the mutation analysis, a set of mutated programs are generated by making small synthetic changes to original program, each of which represents a potential fault in the program. The fault-based adequacy criteria are based on the idea that the test suite is considered effective if it can detect the faults introduced by the mutant program. There are different types of fault-based adequacy criteria, including mutation score, equivalent mutant score, absolute adequacy, and relative adequacy. Now let's see each type with an explanation. Mutation score. It is the percentage of mutants that are killed by the test suite, and the mutant is said to be killed if the test suite produces a different output than the original program. A high mutation score indicates that the test suite is effective in detecting faults. Equivalent mutant score. It is the percentage of mutants that are equivalent to original program and are not killed by the test suite. Equivalent mutants are mutants that have same behavior as the original program. A low equivalent mutant score indicates that the test suite is effective in detecting faults that are not equivalent to original program. Absolute adequacy. It measures the number of faults that are detected by the test suite. It is based on the idea that our test suite should detect all the faults that are introduced by the mutants program. Relative adequacy. It measures the ratio of number of faults detected by the test suite to the total number of faults introduced by the mutant program. It is based on the idea that the test suite should detect a high proportion of faults. At the last, the conclusion. Conclusion says that overall fault-based adequacy criteria are useful in assessing the effectiveness of test cases in detecting faults in the system software, which can help in improving the quality and reliability of the software. Thank you. Please like, share and subscribe my YouTube channel for more educational videos.